Now let's define the second important term in this area, which is a function. A function from A to B. First of all, it's a relation from A to B that has two special properties. And those two properties are, for every element that's in the domain, there is an element y in the codomain such that the xy pair is an element of the function. What this is saying here in symbols is that what? Here's another way to say it. Every element of the domain maps to an element in the codomain. The second part of the definition says, for every x that's an element of the domain, and for every y and z who are two elements in, and they can be the same element, we're going to show they're the same element, for every y and z that are in the codomain. If this ordered pair is an element of the function, and this ordered pair is an element of the function, then the y and z values have to be the same. Another way to say this in everyday language is every element of the domain maps to one element of the codomain. So a quick way of talking about a function is we could say every element of the domain maps to one and only one element of the codomain, which brings us back to another word we used before, the word unique. The word unique in mathematics means one and only one. So we could sum up this entire definition by saying every element of the domain maps to a unique element of the codomain. Let's look at a couple of functions here with some arrow diagrams and ask, are these relations going to be functions? These are all relations from some set A to some set B, from a domain to a codomain. In here, we have A paired with 1, B paired with 3, C paired with 2. Every single element of this domain maps to something in the codomain, so we fulfilled the first requirement. Every element of the domain maps to only one element of the codomain. Since we have this relationship, we can say the value of the function a is going to be 1. And there's lots of ways we can read this. We can say f of a is 1, f at a is 1, the value of the function at a is 1. We can also say f of b here is going to be 3, and f of c is going to be 2. Let's look at the next example. Here we have a, b, c. All of these are mapping to 2. Is this a function? Well, yes it is, because every element here in the domain is mapping to something in the codomain, and every element here is mapping to only one thing in the codomain. So that makes it a function. So this one's a function, and this one's a function. This particular function gives us a chance to talk about another word, the word range. The range is a subset of the codomain that's the image of all of the things in the function. Here, 2 is the range of the function, because everything maps to 2. And our first one, 1, 2, and 3, is the range of this function. So on the first one, the range and the codomain are the same, and on this one, the range is indeed a proper subset of the codomain. You may have learned about functions and done a definition before where you talked about the domain mapping to the range. That is correct, but you're just looking at that subset of the codomain, and we want to look at things in a more general way here. Look at the third one here. A maps to 1, B maps to 2, C does not map to anything. So this one is not a function. Here, C maps to 3, B maps to 2, A maps to both 1 and 2. Since A is mapping to 2 locations, this one is not a function.